Alright, so if something is a polynomial, all of your exponents have to be whole numbers, so 0, 1, 2, 3, 4. So is this first one a polynomial? No, because we have a fraction exponent. Okay, so this is kind of starting back at the beginning of the chapter. Not the stuff that'll specifically be on our quiz tomorrow, but we only have one more section before the test, so good to review it. B, is that one going to be a polynomial?
Yeah.
Yes. If I ask for the degree, since it's factored, you have to think about if I multiplied it all out, what would my highest power of x be? 4. Good. What would the end behavior be? Up for an even, but then
down,
the negative in front flips it, so down. Alright, C, is this a polynomial?
Yes.
Yes. Degree, the highest power is 5. It wasn't listed first, but it's the biggest one. So we know odds look like a chair and a negative flips it, so our end behavior would be
Up, down.
and D is again a polynomial. What's the degree on this one?
7.
And so the end behavior would be in those first few sections, we also talked a little bit about our degrees and maxes and mins. So if I'm looking at this one, it has 3 turning points. So the smallest possible degree would be
E, is that T?
well, the degree is what I'm looking for. So
3.
we have 3 turning points, but if it's an odd degree, the ends would have to be going opposite directions.
So 2.
So 2, but we have too many turning points for 2. So it would have to be 4. Remember, the number of turning points is always 1 less than the degree. Degree is 1 more than your turning
So
points.
how did you find 4 then?
There were 3 turning points,
And
so it would have to be at least power 4. Or another way to think about it, if you draw a horizontal line, like I didn't put the x and y axis on here, but if I drew the axis here, it would hit 4 times. So if it has 4 zeros, it has to be degree 4. So that's another option. Domain, as we go from left to right, keeps going both directions, so the domain is everything. Range, from the bottom, it's going down forever, so it's coming from negative infinity. But my high point is, the highest is right here, so the y value of that is AB is the point, so we'll just say B, because the range is the y of your ordered pair. Alright.
We have to put that like bracket or whatever.
Yes, because remember, brackets are equal to and parentheses are not equal to. So since it was an actual point, we would do that. Local max and min. So local max, these are ordered pairs that are high points on my graph. So we have, looking at our turning points, there's 3 turning points, so 3 options. Which of them are maxes and which are mins?
A, B, and C, D.
And local min?
B, T.
Okay, absolute, highest or lowest on the entire graph. So is there a highest point on the entire graph?
Yeah, A, B.
AB. Is there a lowest point on the entire graph?
E, T.
ET, but these ends have arrows, so they're going to keep going down. So we don't have a lowest, we just say none. Alright, so that's kind of like the section 1 stuff that we did. Do you guys remember most of that?
Yeah.
Okay. Section 2, we started getting into our polynomials a little bit more. So if I wanted a polynomial of degree 8, meeting the following requirements. If negative 3 is a 0, what is the factor?
You say negative 3?
If negative 3 is the 0.
X plus 3?
X plus 3.
And then X minus.
And it had a multiplicity of 4, so we would say to the 4th power.
X minus one.
And that's a multiplicity of 3, so to the 3rd. And if 0 is a 0, what do we have to have? X minus 0, which is the same thing as just x, right? So just a plain x. And that's degree 8, because I have 4, 7, 8. All my x's. Number 4 is more similar to that activity you guys did last Friday when I was gone, and we had a little bit of trouble with. So if I were trying to write an equation, first of all, we look at our zeros. We hit the axis at -2, so what would my factor be? And it bounced, so it is squared.
And there's a negative out in front, right?
Yeah, how did you know that?
Because it's up, down.
So our end behavior is off, so we know there's a negative out in front. Where else do we hit?
Looks like probably three.
So that means we would have to have the only other thing that we could have. So a lot of times we don't have to consider it, but if I want my graph to match exactly, the y-intercept of this is 4. So the point 0, 4 has to be on the graph. We already know that it's going to be a negative in front, but it could be any number, right? It could be -2 or -1/2, something like that in front. If I asked you to find that exactly, I'm just going to keep it as a for a second. We know it'll turn out to be negative. That means if I put in 0 for all my x's, this has to equal 4. So 2 squared is 4 times 73 is -12a equals 4. So my a is -1/3. So my final polynomial is -1/3 times x plus 2 squared, x minus 3. And the only time you have to find that coefficient is if I give you a y-intercept to use.
So does it always get x? But the y-intercept there, is it like always 0? And then
Yes.
plug in to find that?
Yes. Alright, finding the quotient, so this was back when we started synthetic division. So if I'm dividing by x plus 4, we put our -4 out here. Coefficients, I put this one on purpose because we tend to miss a lot of these. It's a 1x to the 6th. There is no x to the 5th, so don't forget your 0x to the 5th. -16x to the 4th, 0x cubed. 1x squared, 0x, and -16. Lots of people are forgetting the zeros on these. So 1 comes down, 1 comes -4, plus 0 is -4. 4 times -4 is 16. And you guys are doing okay with actually working out the synthetic division, aren't you?
Well, where do you get these zeros from, though?
The missing powers of x, because it went from
Oh,
x to
yeah.
the 6th to x to the 4th. Alright, so then my quotient, that's my remainder constant, and so forth. Your power always drops down by 1, so it's just x to the 5th. Minus 4x to the 4th. 0x cubed, 0x squared, I don't have to include. 1x minus 1. So that's kind of all the old stuff. Everything from here on out will be what's on your quiz tomorrow. So first thing, we've talked a little bit about the zeros of a polynomial. And I've told you that if you have an imaginary 0, what else has to work? Imaginary zeros come in pairs. So if you have one imaginary 0, the conjugate will also work. That's not for real numbers, just the imaginary numbers. So I'm asking you to give me the remaining zeros. If 3 is a 0, nothing else has to be. But if 6i is a 0, what else would I have to have? If -4 minus I is a 0, what do we have to have? Just -4 plus I. You only change the sign on the I portion. And if 3 plus 5i is a 0, we also have 3 minus 5i. So this is easy points if you remember that on the quiz. So there'll probably be a question like this. I give you some zeros. Any imaginary one, the conjugate is also going to work. And conjugate only changes the sign on the I term. Right. And I told you it was degree 8. We have 2 3's, 6, and 4 minus I, 3 plus 5i, and we got our other 3. So we have all 8 zeros there. All right, next thing we did in this was graphing our polynomials. So we'll do a graphing and then talk about problems like yesterday. So our graphing, we have to look, what would our degree be if I multiply this all out? 5. In behavior, we know if it's an odd degree, it looks like a chair, but the negative in front will flip it.
Up, down.
So I currently know when I draw my graph, it's going to start up here and end down here. Zeros and multiplicities. What makes x minus 1 equal 0? Well, just, if you solve it, you just get x equals 1. So we just say the 1, the 0 doesn't include an x. But since it was squared, that would be multiplicity 2. If I set x minus 3 equal to 0, we get, and if you set x plus 4 equal to 0. So that's where I'm hitting my x-axis. -4, 1, and 3. Okay, how do I know if I go through or bounce?
Even or odd.
Even or odd multiplicity. So 1, 2 is odd, so bounce. At 3, -4, that's just a multiplicity of 1, so it will go. And y-intercept, that's when x is 0, so if we put in 0 for all of our x's in this equation, so 0 minus 1 is -1 squared, 0 minus 3 is -3 squared, 0 plus 4 is 4. So what do we get? 1 times 9 times 4. -36. I'm not going to, I'm just going to mark a point and say that's -36. So that's where I hit my y-axis. So my graph, I just start up here. At -4, we said it would go through. Have to cross the y-axis at -36. At 1, we said our graph would bounce. And at 3, it bounces.
Let's plug in to get your y-intercept again.
A 0. A y-intercept, if you're crossing the y-axis, x is 0. Alright, so your quiz is basically like from question 6 on. So are we okay with this? On the quiz, I would step it out just like that. I would have my A, B, C, D, E telling you what to do. You just have to be able to find each thing. All right. Question number 8 is really combining what we did yesterday and our graphing piece. So it's putting all of it together. If I look at this, how many zeros is it going to have? What's the degree?
30.
So your degree is your number of zeros. So we will have 3 zeros on this. So the maximum number of zeros is 3. My degree is 3. They're the same. In behavior is going to be what? Now this one, it's not factored for me to graph, and it's not something I could factor easily. So we would have to do the possible zeros here. This is from yesterday. So remember to do that, we do P, Q, and possible zeros. So what are my P values?
Isn't that -12?
So everything that goes into -12. So that would be 1 and 12, 2 and 6, 3 and 4. Q, everything that goes into the leading coefficient, which is just 2. So everything that goes into 2 would be 1 and 2. So remember, possible zeros, that's P divided by Q. So 1 over 1, 1 over 2, 12 over 1, 12 over 2, 2 over 1, 2 over 2 is 2, we already have that. 6 over 1, 6 over 2 is 3. 3 over 1 I have 3 halves. 4 over 1 is 4, and 4 over 2 is 2.
Did you use 6 twice?
Oh, yeah, I did, thanks. Alright, so that's everything that might work. Now what do we do?
Test it out.
Yep, and so to test them, you are taking this equation, plugging those numbers in for x, and seeing what works.
0.
Right. So once we find one that equals 0, we do our synthetic division. So 2 comes down, 2 times -4 is -8, 3 plus -8 is -5. 5 times -4 is 20, plus -23 is -3. 3 times -4 is 12, so that's 0. So we have 2x squared minus 5x minus 2. We do our slip and slide. X minus 6 and x plus 1. Divide our 2 back. So x minus 3, 2x plus 1. Here, I didn't even ask for the factored form, I just asked for the zeros. So what makes x minus 3 equal 0? Positive 3. What about 2x plus 1? And what else do I need on my list? -4. We said we could have 3 zeros and we got them. And we know those zeros are where we hit the x-axis. Because this one I'm having you graph as well. Okay, will it go through or bounce at these zeros? They all have a multiplicity of 1. 1 is odd, so it will go through all of them. And y-intercept, if you go to your original equation, you put in 0 for all of your x's, we get -12 out. On your y-intercept on your graph, if you are just putting a line and putting a point there, make sure you label that that's -12. So my graph, I had to start down here, go through, hit my y-intercept, come back and go through. So the final graph looks like this. Can we handle all of these on the quiz tomorrow? Can I do one final question and then I'll let you guys work? So last thing I might put on the quiz tomorrow is something like this. When I give you the first 0. The only difference is the first 0 here is imaginary. Does that change anything? Nope. When you have the first 0, you do synthetic division. So 3 comes down. 3 These are not like terms, so I have negative 1 plus 9. So I'm gonna have 3i times negative 1 plus 9i. That's negative 3i plus 27i squared. And 27i squared is, so I'm gonna add those, the 27's drop. 3i times negative 3i is negative 9i squared. What do we do now?
Multiply it by, or divide it by something else, divide it by a negative 3i.
Yes, because imaginary zeros come in pairs. If you have 1, the conjugate works. And this time all the i's should disappear. So 3 comes down. 3 times negative 3i is negative 9i. Add those and get negative 1 times negative 3i is positive 3i, and that gives me 0. So this is 3x minus 1. Question was the remaining zeros, so we don't have to list 3i because I gave that one to you.
1/3.
So the negative 3i that we had and the 1/3 are my